What is up, one and all? We got GAC closed tomorrow. I just can't believe it. We've got another snow day, ice day. Oh, gotta love Cyber Days, and we are going to keep grinding. We are building our house every single day. It makes me so excited. Just absolutely makes me so excited. You might say, Coach, how excited are you? In fact, right now, guess what I'm doing? I am literally, it's Tuesday night. It's 11:22 right now. And for the next 20 to 30 minutes, I'm going to spend doing some AP stats. Can it get any better than this? Serious. Can it get any better than this? Here's the deal. I love y'all. I care about y'all. I want y'all to be successful. So what I've decided to do, I'm going to turn down Justin here. Appreciate you, Justin. As much as I care about y'all, I really want y'all to be successful on this next test and in preparation for that. So I'm just going to ask that as we go through this process that you continue to buy in, you continue to ask questions, and we'll rock and roll from there. So let me go through the checklist real quick. And it's pretty simple what the expectation is, but I hope that this is going to be not only beneficial for you, but not a waste of time as we go through. I will tell you that this podcast is very, very important. You might say, how important? Well, I'm writing right now, right? Very, very important. So make sure that you please watch this. It is so imperative that you know what we're doing today, okay? I don't think it's very difficult. I think it's very similar to what we did with proportions. If you still struggle with that, go back, watch podcast, review, do an FRQ or two off the packet. I think that would be huge there. Then I need you to complete 2 FRQs. The reason why I need you to do that is just so that it shows me that you are that you're engaged on Cyber Day, and that they just kind of hold you accountable to make sure we're just gradually doing what we're supposed to be doing. And so it just kind of helps me to see who's engaged on Cyber Day. And then I just need you to submit that online by midnight. All the FRQs should have their answers on the backside. If you don't, please let me know, and we'll touch base on that. So it's not something where, I know you could copy it. My big thing is I would take it, do the best you can in describing it, and then come back in with another color and correct it, fix it. That's how you'll learn, is having that growth mindset of knowing that you may not get it perfect the first time, but just trying to attempt to gauge, hey, what don't I understand, and then attack it that way, okay? My attempt today is to go over all of section 7.3 today, mainly because we've already done the penny activity, which was really the first part of 7.3, and you'll see why here. But we're going to do that today. Also tomorrow at 11, so this is January 17th from 11 to 12. I'm going to go on and just answer any questions. This is my help session time. I'll send out the link, so if you have any questions on this, you could just ask me. If you have questions that's later on than that, I can answer it via email. But this will be a time where you could actually go on like a study session online to be able to do that there. So from 11 to 12 is kind of what I'm thinking there, and we'll rock and roll on that. But again, if you have questions later on, feel free to do that as well. Couple of things I want to talk about real quick. This is a good AP exam note. We've talked about p-hat, the sample proportion, x-bar. We talked about is our sample mean. We've got our true proportion, or my population proportion, population mean. We've got our standard deviation, right? This is for our population. We've got the mean of our samples, right? Or of our sample proportion. We've got the standard deviation of our sample proportion, and then the mean of our sample means, and the standard deviation of our sample means too. Here's the deal. Just kind of read this note. If you can't use it correctly, don't use it at all. Just make sure you describe it in words. A lot of times the notation will help you with that shorthand to be able to get the information down you need. But just again, kind of focus in on those symbols. Make sure you understand that there. I know I'm kind of hopping all around, but I'm just kind of, before I get into the notes, just going through a couple things. This right here were the 2 pictures from our pennies activity. If you remember, many of you had a population and I'm just throwing this down here, okay, had a population dot plot or a population distribution that was skewed to the right. The main reason why is because there were more values that were on the more new side than those that were later. The reason why is because anytime we have money, we understand that the longer that, or the older they are, the more opportunities they have to get lost. And so this traditionally will follow a population distribution that's skewed right. However, when we did a sampling distribution, just like we talked about with the proportion, when we talk about our mean, okay, and you might say, Coach, what's the difference with what we did earlier with what we're doing now? The only real true difference is now we're trying to sample, doing a sampling distribution where we're focused on our mean instead of our proportion, okay? So we're focused on our sampling mean as it relates to our sampling distribution. So we're taking a sample, finding the average of that, and that's what each of these note cards represents. For my second class in 7th period, we had n equals 40 or 40 total samples that were taken, right? That's what we've talked about. In that case, we took a sample size of 3, so we averaged 3 pennies together for each of these note cards, right? And you see that even though it's skewed right with the population, you see that it's approximately normal, and it might be a little bit off, but approximately normal within this distribution. As we look at the sample size of 10, when we average together, you'll see that this too has a approximately normal distribution. If I had more, you would see that even more defined than what you see here. But this would have a approximately normal distribution, okay? And because of the fact that the sample size was 10, when we increase the sample size, what happens? Well, you'll notice that the variability from here to here was actually less than, and it's actually from here to here, was less than the variability from here to here, because as the sample size increases, so the variability decreases. And we'll remind you again that later on. But just wanted you to see that. The 2 FRQs I want you to do today, after it's all said and done, is this one, the statistics A, C, and D being unbiased, okay? And again, if you have questions, I would say also from 11 to 12, contact me there. And then also this one, the one that talks about trains, okay? You could do those 2. I think those 2 would be pretty good to go through. The one that we may talk through in class, like I did today, was just kind of talk over this one specifically from C and D, how that differs from A and B, okay? And you'll actually see me do one in just a little bit. Now, as we go through this, I think it would be good for you to have the big picture of what we're talking about. First off, we remember chapter 6 was our bins or our binomial stuff. We talked about something that's binomial, independent, has a set number, and has the same success percentage. We define that as bins, and we use our standard deviation and mean formula as you see here, okay? The part you see on this side is this would be like binom, PDF, or CDF rather than the formula more times than not, okay? So just a heads up on that. But this is not what we're talking about in Chapter 6. I just wanted you to get the big picture. But we have talked about the sample proportion or sampling distribution as it relates to proportions, as you see everything on the left side. Now, the only difference is we're going to compare now the sample means. One thing to remember is this is very, very important, okay? Very, very important. Those that are in Sweden, please highlight this, okay? And those in my AP Stats team, you might want to highlight that too, okay? Big deal here. Couple things you need to know on this that just really kind of stand out. First thing, what is the parameter? Well, instead of P, we use what we call mu, okay? This is the mean of the population. The statistic or the sample related to the sample of that mean would be X bar. Again, nothing different from what we've done previously. When we draw a sampling distribution, okay, here we go again. We've got this here. Same idea. P is related to you'll notice that P is related to my parameter. Therefore, same idea. Mu is going to be related to my parameter as well. Okay, so these are very similar. This is also a sampling distribution. And the sampling distribution comes from X bar. And what that means is the mean of each of my samples that I'm taking, right? So every time I draw 10 pennies, I'm averaging those together, which is X bar. It's a sample of my population of the total 25. And again, that's how I would get that one specific data point there, okay? Now, this is a little different. When we do approximately normal, we still use CLT, except there's two different conditions. Condition 1 says, if population distribution is normal, then sampling distribution is normal, okay? I'll erase this for later on, okay? Pretty simple, right? Population distribution, if it's approximately normal, sampling distribution can be approximated as normal. Now, if the population distribution is not normal, okay, then we got to use something, we got to have one condition to be able to meet. We call that our CLT. So if it's not normal, we use CLT, which for means is pretty simple. If the sample size is 30 or greater, we say that it meets the CLT. In fact, in one of my classes, we had less than 30 trials, or 30 samples rather, that we took, and therefore it could not be approximated as normal. While my other class had 40, and that exceeded the 30, so we could say that it did follow the CLT, or central limit theorem. If you want to pause this right now, get this, because I'm going to erase this here. The next thing is, what is the mean of the sampling distribution? Well, if mu of p hat is equal to p, then mu of x bar is equal to mu. So the mean of my sample means, is going to be equal to mu. And in fact, we say that it's equal when it is unbiased, okay? If it's sampled appropriately. The next part we have is the standard deviation of x bar, so the standard deviation of my sample means, is equal to whatever my original standard deviation is divided by the square root of n. Okay, again, you're going to see this again. Just want to make sure we're good. The condition for using this standard deviation formula is actually the same thing here. So it's got to satisfy the 10% condition. So it's actually the same. 10% condition is for both. And then finally, the formula for the z-score, a lot of times you'll see it as x minus x bar, or x minus the mean, right, divided by my standard deviation. Well, the original value was x bar minus mu divided by my standard deviation over the square root of n, okay? This would be my z-score formula compared to this, which should make sense because this is my original value, whatever value I'm looking for, minus mu, which is my center, right? It's my mean of my sampling distribution, and then divided by my standard deviation, which is this formula down here, okay? Now, what does this look like? How do I put this into practice? We're going to rock and roll on this really quickly. And in doing so, hopefully this will make sense. This activity I'm not going to do because of the fact that we've already done the pennies. So as we go through it, just kind of think of the pennies and how we did that one. And we should go fairly quick here, okay? The situation is we've got a high school, GAC, with ACT scores for seniors, okay? Aren't you glad ACT scores are over with? Isn't that beautiful? Oh, man, ACT is done, SAT is done, at least for, I think, a lot of you, which feels kind of good, I bet. But the population here, when we look at this, is all seniors at GAC, okay? So, again, focusing on just GAC seniors, okay? Now, the parameter is related to my population it's the value associated to my population. So it says Coach J goes up to GAC, selects at random 5 students. Okay, I'll go through that in a second. It says an average ACT score of 16. So I would say my mu is 16, and my true standard deviation would be 5. Okay, because again, it gave it to me here and here. Okay. It then asks, what is my sample? Well, each sample that is being tested, the fact that goes up to GAC to select a random sample of 5 students, he will find these 5 students and record each of their ACT scores and find the mean of the sample. So this is a sampling distribution because, again, we're going to take 5, record the mean, and we can keep doing that over and over and over again, making it into a sampling distribution that's there. Since we only took 5, though, we are taking how many students? Well, we're taking 5 students that's there. Now, as we simulate taking a sample of these 5 students over and over and over and over again, what we're going to do here is I'm going to make up a value and say that the X bar of these 5 students would equal 15.6. Now, it could be anything. I didn't go in to y'all's records. I know that you're happy about that, to find your ACT score and then do this. But think of this as the pennies activity of taking 5 pennies, recording it, and putting it right here, okay? Now, as we go through, remember that I had y'all do it 5 different times. So let's say I did 5 again, and let's say I got 18.2. Let's say I did 5 again, and I got 20.6. Keep going, 14.4. And let's say I did it again to get 15.0, and I'm just kind of making this up, and then 17.2. Now, what would the sampling distribution, what would that look like? Well, we know that because of the fact that mu is 16, and we remember that for what we had talked about previously, that the middle value would actually be mu. We can expect that most of the values, when we did this, would fall underneath 16. And then the second would be like to the left and then slowly progress downward here. The only condition that needed to be met in order to say that it's approximately normal is it would have to follow the CLT. And because we're doing sample means, we'd have to make sure that n is greater than or equal to 30, meaning we would have to do this 30 or more times to approximate this as a normal distribution, okay? And again, we approximate what? Well, this is a sampling distribution because, again, I'm taking a sample of 5, recording the mean of those 5, and then I keep doing that over and over and over again, okay? Remember, it's a sample of a sample, okay? Sampling distribution, it's a good term, is a sample of a sample, okay? Of a sample. A sample distribution is just like if I took 50 of GAC's students and recorded their ACT, each student would represent a specific dot. That's the difference between what we've done previous to where we're headed. Now, what if the population distribution was not normally distributed? We talked about this. Would the sampling distribution still be approximately normal? That's possible, possibly. Now the question is, what happens to the sampling distribution if we increase the sample size? Well, remember we talked about this when we went through, I think this slide, right? As we increase the sample size within my pennies, the lower the variability, and I know it may not look this way here, but it would actually look more normal the higher the sample size there. So we would say lower variability, and it would also be more normal. Okay? More normal. Now the possibly part, remember, the reason why is we wanted to make sure that n is greater than or equal to 30. That's here. Now, if the population distribution was normal, this does not even have to be done because it will be approximately normal in that sampling distribution. Okay, so remember the conditions that we talked about. Okay, Now I want you to pause this real quick, okay? And I want you to see if you could do numbers 1 through 3 and then check with me. So pause right now and even try to go even further down, and then we'll get to it, okay? Ready? All right, we're back. Now, averages or the means are more or less variable than individual values. Well, if I average it, rather than just take an individual value, wouldn't the average kind of even each other out? So if I have a really old penny and a middle of the road penny, they would average out to hopefully make it less variable, right? In fact, it would be less variable when we did that compared to individual values. So this is a sample distribution, and this is more when we take a sample of a sample. This would be a sampling distribution, okay? Averages are more or less normal than the individual values. Well, it's going to be more normal, right? Because we kind of get rid of those outliers that are there, and it would follow more of a normal curve. Think of this in terms of the pennies activity. Compare the population distribution to our sampling distributions and how that looked in terms of being skewed compared to being normal. Number 3, increasing the sample size blank the variability of the sampling distribution. It decreases. Okay, remember increase, remember our hands, increase sample size, we decrease the variability. Okay, let's go over 7.2 real quick, make sure we hit on this. 7.2, we looked at proportions. Remember that we were in search of a proportion of the population. The actual proportion of the entire population is called a parameter, the actual one. It's denoted as P. The estimate of the proportion based on a sample is called a statistic and is denoted as P hat. Okay. An example of this we talked about, I think the one we used a lot was the proportion of orange Reese's. Okay. Or orange candy. Remember the candy machine one? That would be more of a proportion of orange Reese's. Now we're going to look at means here. The actual mean of the entire population is called a parameter. We call that mu. And sorry, that's awful mu. Sorry about that. Sorry, Sweden followers. My fault there. My BAD. We've got our statistic, and this is denoted as X bar. Okay. An example of this, we talked about ACT scores. The one we really did that I want you to focus on is our pennies activity, where I averaged the pennies together, right? Average the 3, average the 10, and then we got those values that are there. Okay, all right. This is just a quick memory, just in case you forgot. Man, I love this. This was such a good day. Let me see if we can. There you go. Let's see if we can see y'all. See if I can see anybody. That Mary Martha. Look, Mary Martha's bebop. There's Maria. What's up, Maria? Got Grant over here. Let's see if we can see anybody else. Nicole's right here. Is that Addie? Right there? I think that's Addie. It's hard to see. Let's see here. Any other people in my AP stats? Just those two. Oh, Campbell. Look at Campbell there. Looking off in the distance. I love it. What a great day. Love that. Very much so. Okay. Now, I think I'm missing a thing of notes here. If you look at your notes, it says, let's fill in those blanks really quick. I think I've already done this. It says, suppose that X bar is the mean of an SRS. I forgot to do that one. Of size n drawn from a large population with mean of mu and a standard deviation of theta. If the population distribution is approximately normal, then the sampling distribution is approximately normal. Okay. So again, just a heads up on that. If the mean of the sampling distribution of X bar is, just remember too, this would be the next blank. So we would say the first blank would be normal. The second blank would be mu of X bar is equal to mu. Again, these are from the notes we've already kind of took here. The standard deviation of X bar is equal to the standard deviation over the square root of n, as long as 10% condition, which is occurs. So this would be, for instance, the n is less than or equal to 1/10 of my population. So make sure of that. So if it is normal, or if it's not normal, right, in terms of the population, but it follows CLT, okay, then what we can do is when we write this, you can write our normal curve, okay, we got mu in here, and we would say that the normal distribution would be n, mean would be mu of x bar, comma, standard deviation of x bar, okay? And then we can use the normal CDF like we did with a proportion, and then attack it with that there, okay? The bottom part says look back at the formula for standard deviation. It tells us that the standard deviation decreases as the size of the SRS increases, which should make sense because the standard deviation will decrease, or the variability will decrease, as our sample size increases, okay? Here's one thing. If we want to cut the standard deviation in half, look right here, okay? If I want to cut this standard deviation in half, I would have to just divide this by the square root of what? Well, I'd have to divide it by square root of 4, right? So what we would say is that in this example, because remember the square root of 4 would be 2, so if we want to double this, double the standard deviation, then we must multiply the sample size by 4. Because again, if you think about it, it is the square root of n, whatever n is. So if we want to double that, we would have to multiply it by 4. And again, all it is this statement is using whatever is above here. So whatever my sample size is, we want to multiply that in order to get what's there, okay? In order to double that standard deviation. All right, so with all of this being said, and all of this being done, here we go into problems here. And I'm going to do it based on the z-score formula. If that's not how you do it, you could do the normal CDF. Your answers may be a little bit off from mine, but that's okay. I'm going to finish this up right here. I'm going to finish this one, these 3 up, and then we will be done, okay? All right, so let's look at this. Let's identify what type of distribution we're focused in on here, okay? It says the height of all GACS seniors approximately follows a normal distribution of the following, okay? Gives us this here, where the height is in inches. It says pick A, 1, GAC senior at random. All right, so since we are only taking 1, we are taking 1 from where? The population. So my focus is on the population distribution. Now, because of the fact that this is a population distribution, I'm going to put these down here. I'll bring these back up. Since I'm focused on that, I'm not going to even use anything with a sampling distribution because it is a GAC senior. I'm showing you the difference from what we've done previously. So since it follows a normal distribution, we're going to put n is 68.8, comma, 3.5. We're going to put 68.8 here. Okay, that's in the middle. And since this is my mean here, the question is what is the probability that their height is greater than 70 inches? So I'm going to put 70 over here, label this, and all I'm simply going to do is highlight the area that I'm trying to find. Okay? So with this, we can go straight to my z-score formula, which is x minus mu all over my standard deviation. Notice that there's no difference because of the fact that it is a GAC senior. It is from my population distribution since it's only 1. So we could plug in my x value of 70 minus my 68.8, which was my mean, okay? Divide that by 3.5 to equal 0.34, okay? And so my z-score, when z is equal to 0.34. That is, remember, z-score is the amount of standard deviations from the mean. So this is saying that there's 0.34 standard deviations to the right of the mean. If it was negative, it would be to the left there, okay? So as I look at the area that's underneath this, I can find everything that's to the right of this value, because that's what my z-score table can find. You could also do, if you wanted to, you could do normal CDF from 70 to infinity, okay? Lower bound, upper bound, just make sure you have context there. And all I would say here is that from 0.34, I end up getting a value of 0.6331. So that's the amount, that's the area that's in blue. So to get the yellow area, I can do 1 minus that, because the area under the curve is 1, to where I would say that the area is equal to 0.3669. Now, in interpreting this, this is my answer. In interpreting this, we would say that I would just restate it. The probability that the height of an individual, of a GAC senior that's picked at random, that it's greater than 70 inches, would be 36.69%. And I would leave that as is. That's how I would interpret. But just be sure that we do interpret that within all of these, okay? Again, this is for a population distribution, a little bit different with when I'm only finding one student, okay? Now let's go to my next one, and you're going to notice the difference here on number 2. Notice, pick 10 GACS seniors. Find the average of their heights. Now, once I do this, now I'm going to a sampling distribution, okay? So I'm taking 10 and averaging it together to get one specific value. So it says, what is the probability that the average of their heights is greater than 70, okay? So let's talk through a couple things. A lot of times we can do state, plan, do, conclude, stating what the problem is, planning, doing, and concluding. You could do it that way. It's not required, but you can. Let's talk through a couple things here. First off, we know that the distribution is normal, okay, because it gave it to us. So if the population is normal, therefore we can assume that the sampling distribution is normal. So we say if population distribution is normal, then sampling distribution is normal, okay? So we state that. So we got our normal. We don't have to do CLT. So because of that, we go straight into our normal distribution. But the problem is remember that n is mu of x bar, comma, standard deviation of x bar, right? That's what makes this up. So let's talk through a couple things. Let's talk through what is mu of x bar equal to. Well, that is equal to mu. Well, mu is, it gave it to us, 68.8. So we can just keep that in as this value here. So this is 68.8 as my first value. Now my standard deviation of my sample mean there is equal to the standard deviation, original standard deviation, divided by the square root of n. So I'm literally plugging this in by doing 3.5 divided by the square root of 10, which produces a value of 1.107. So this will go in right here. Okay, so we've got our here and here. Now, the one thing I did do that I forgot, but I can state here, is I can't do this standard deviation formula unless I show that n is less than or equal to 1/10 of my population. So that means that 10 is less than or equal to 1/10. Sorry, I will put this here. 1/10 of my population. So I could multiply this by 10 on both sides to where, can we say that 100 is my n, or my my population numbers, the amount that are in my population, is that greater than or equal to 100? Yes, because of the fact that there are more than 100 GACS seniors. So we can say that yes, we sure can. So based on the 10% condition, I can use this formula that you see up on top. So we've got everything established. We can use this normal distribution curve. It says, what is the probability that the average of their heights is greater than 70? Same question, just a little bit different with the sampling distribution and how I approached it. So now we approach it in terms of my z-score again. That equals my x minus, we'll keep it here, x bar minus mu divided by standard deviation over the square root of n, right? We know that this right down here is 1.107. X bar is 70, and my mean is 68.8. Okay? Now, I'm plugging that in. We get out 1.08. So what does that mean? That means, again, that is 1.08 standard deviations away from the mean. You'll notice that this is much more, this is a little bit spread out. You'll see kind of how it changes a little bit in just a second. But as I plug this in, we find the area underneath. The area that is to the left of this would be 0.8599. So to find what the yellow part is, sorry, 0.8599, I was trying to do a percentage. We take 1 minus that to get equal to 0.1401, okay? And again, interpret is the big thing. How do I interpret this? I would say 14.01% of is the probability that the average height of 10 GACS seniors, or the average height of 10 GACS seniors, is greater than 70 inches. And so that's what we would be looking at right there. Okay. Alrighty, let's go to our final question that's here. This one is pretty much the same thing, so I'll rock and roll through it. All I'm going to do, though, is same idea. You still want to go through this to where the only difference is because this is 50 instead of 10, the variability is going to change. It's going to decrease a little bit, so we're going to push this normal distribution closer together to where big N is 68.8 at the start. And then comma, my standard deviation of x bar. Remember, the standard deviation of x bar, first of all, mu of x bar is equal to mu. That's why this is 68.8. Again, this is a sampling distribution because I'm taking 50 and averaging them together. We're just looking and seeing what's the difference between 10 and 50. So we're going to take the standard deviation divided by the square root of n. So this would be 3.5 divided by the square root of 50. And when I plug that in, we get, we know 68.8, but this would then be 0.495. Notice the standard deviation decreased as sample size increases, okay? Because, again, standard deviation is the average distance each value is from the mean on that, okay? We're still looking for 70, so 70 or greater than 70 is what we're looking for. Remember, in order to do the standard deviation of x bar, I would have to show that n is less than or equal to 1/10 of my big N. So if this is, this actually might not work, so this might actually be pretty nice here. We're going to assume that it does work, but as I look at this, because of the fact that as I multiply this, 500 is 500 less than or equal to my population, that's not true. That's actually going to be larger than. So I actually wouldn't be able to use this formula, but we're going to pretend like GAC it has more than 500 seniors in its class, okay? So we'll continue that there. So as we do this, the z-score still would be the same. Z is equal to 70 minus 68.8. Now, I would probably make this a little bit neater. And I wouldn't be doing this formula, which would nix the problem, but just in case. We got Z is then equal to 2.42. Notice it's further away from the mean because the variability is much, much closer together. So we would say that 2.42 is the z-score, to where the area underneath this curve would be 0.9922. To find the blue area, I would do 1 minus this to say that the area would be 0.0078, and that would be the area here. Now, just to give you context, the original value was 0.1401 up on 10, but notice that the probability of getting 70 to sampling 50 GAC students, finding the average and having that average be 70 or greater, that probability is 0.78% compared to the 14.01%. The reason why is because as the variability, or as the sample size increases, that variability decreases, making that 70 a little bit tougher to get when we have 50 individuals that we're averaging together. Okay. Hey, I hope this was helpful for you. You'll notice that this also kind of goes and ties into this question where it says if the filling equipment is functioning properly, what's the probability that the weight of the ore in a randomly selected car? So this is like my population distribution. But this one is what is the probability that a random sample of 10 cars? So now this is my sampling distribution. But same kind of idea. Use that and really rock and roll from that there. Hey, I appreciate y'all tonight. I know right now it's 12:03. Hopefully this podcast was helpful for you. Post those FRQs and get those in and rock and roll. Care about y'all. Have a great Cyber Day, and we'll see y'all later.